Okay guys, so i-discuss lang natin yung session 2 or yung topic na strain. So i-summarize lang natin. And itong i-discuss ko is yung nasa workbook ninyo. So before that, basahin muna natin yung quote na sinulat ni Ronald E. Osborne. So sabi niya, unless you try to do something beyond what you have already mastered, you will never grow. So pwede niyo siyang i-relate dito sa ating workbook, yung mga problem set dyan. So, kinategorize ko siya do sa mga easy, moderate, and hard problems. So, syempre, yung mga easy problem, so pwede nyo sabihin na ito yung mga type ng problem na kayang-kaya natin sagutan. Pero kung hindi mo explore or hindi mo iano yung boundary na yun, hindi mo lalagpasan, i-try i-solve yung moderate and yung mga hard problems, hindi ka mag-grow. So, ayan, that serve as a inspiration para sagutan natin yung mga problems sa inyong workbook. Alright? So again, strain as an introduction. So under this session, we begin our study of an equally important topic of mechanics of materials, which is about the deformations. Okay? So under strain, ayan, puro deformation yung pinag-aralan natin or yung strains. Okay? So as defined, so yung strain is defined as a geometric quantity that measures the deformation of a certain body. So there are generally two types of strain. So the first one, the normal strain. So this characterize the dimensional changes. And yung shear strain, so ito naman yung nagde-describe ng distortion or the changes in angle. Okay, so again, a normal strain for the dimensional changes, and for the shear strain, yung distortion niya. Okay, so the mechanical properties of material are defined by the relationship of stress and strain. So, doon sa mga video lecture natin, kung maaalala, may mga problems kasi doon na yung given allowable stress yung ginamit natin. Kasi as discussed, di ba may formula tayo doon na PLAE or yung the actual deformation, yung PL all over AE. From where yung P over A, so that is equivalent also sa stress. So under session 1, di ba? Although our emphasis in this session will be on actually loaded bars, so mostly naman problems na sinolve natin is under the, ayun nga, actually loaded bar or yung mga problems that involves the change in temperature. So yung shear strain, ayan, formula based, and nagpakita rin naman ako ng example. Pero mostly, lahat ng mga problems or kalimitan ng problems, especially yung mga lumalabas sa board exam, dun sa normal strain, where it involves yung axial forces and yung the change in temperature. Okay? So the principles and method here apply equally well to more complex cases of loading discussed later. Among other topics, we will learn how to use the force deformation relationships in conjunction with equilibrium analysis to solve statically indeterminate problems. Okay, so using equilibrium analysis and at the same time, yung relationship ng force and deformation. So, dyan natin na bubuo yung mga equation in order for us to solve for the problems under the topic of strain. Okay, so let's move on. So, what is this actual deformation or yung stress and strain diagram? Ito may discussion rin naman ako sa mga video lecture natin. So, the stiffness of a material, okay, is often equally important when designing machine parts or structures as are mechanical properties such as, ano ba yung mga to? So, we have the hardness, the toughness, and the ductility. So, bawat materials na ginagamit natin, especially in a structure or even in a machine part, may kanya-kanya kasi silang material properties. Okay? So, dyan na nga pumapasok ito, yung mga hardness, yung toughness niya, and ductility. So, these properties are determined by laboratory test. So, before, yun nga, as QA/QC before sa Dubai, pinapadala ko ng company ko do sa mga third party or yung mga laboratory nga namin dun So, nagwi-witness ako kadalasan ng mga test na ginagawa namin sa mga materyales. So, dyan papasok yung concrete, yung steel mo, yung mga paving blocks, mga tiles, sari-saring test yung kinoconduct dyan. Para ginagawa mo kasi siya to check if you meet the specification of a certain project. Okay? Or lang yan, for quality assurance din, quality control, titingnan mo if yung napapaabit sa site mo is, ayun nga, as per project specifications. Many materials, particularly metals, have established standards that describe the test procedure in detail. So maraming test yan, So the most common test conducted on a steel is the tensile test, which will be used to illustrate the different material behavior. So yung pinaka-common test nga na ginagawa for steel is the tensile test. Okay, so under tensile test, ito yung nangyayari dyan. Ito muna pala is yung normal or yung axial strain. So ang sinasabi lang dito guys, ayan, i-ano ko lang ito, So originally, yung bar mo has a length of L. Ngayon, because of a tensile force here, this is the undeformed state. So before mo i-apply yung load, yung undeformed state niya is ganito. Originally, ganyan yung iyong bar. But because of this axial load P, kung mapapansin natin dito, nagkaroon ka ng deformation. Nag-elongate yung bar mo. Which result, yung total length na ngayon ng bar natin is L plus delta o yung bulate nga. The equation for our strain is given by the equation na strain or yung epsilon is equals to delta over L. Okay? Oh, sorry. Yung highlighter natin. Ayan. So, ito yung ating equation na gagamitin dito. So, that the strain is just the ratio of the deformation over L, or the original length of the bar. And this strain is unitless. Okay? The strain describes the geometry of deformation. Independent of what actually causes the deformation, the normal strain, or also known as the axial strain, epsilon, or yung E, yung pinasosyal nga na E, is defined as the elongation per unit length. So considering the elongation of the prismatic bar of length L, as shown in the figure, the elongation delta, so pa-correct na lang ito guys sa inyong So this is delta, may be caused by the following. So ano ba yung nagko-cause ng yan, yung delta na yan? So una, ito nga as shown, meron kang applied axial force. Next, yun nga, expansion due to the increase in temperature. And last, yung combination nitong dalawa. Even a force and a temperature increase acting simultaneously. Okay? So again, for this discussion, so this epsilon or this strain, please take this note. Okay, so ito yung isa sa mga equation na gagamitin talaga natin, and we will use this to derive the equation for the deformation delta. Alright, so next, dumao naman tayo do sa letter B, or yung tension test na nga, tinatawag. Ayan. So, under tension test, so ito, meron kang specimen used in the standard tension test. So, meron silang sinet na gauge length. And ito, ikinaabit siya sa machine kung saan yung purpose ng machine is to pull or binabatak niya yung iyong specimen or yung sample na pinadala. So, meron kang tensile force P. Ayan, pinapakita dyan na hinihigit. So, this is a machine usually calibrated naman yan. In the standard tension test, the specimen shown in the figure is placed on the grips of a testing machine. Ayun nga. So, nakasalang siya sa machine kung saan this is designed so that the load P, ayan, applied by the machine is axial. So, 2 gauge marks are described on the specimen to define the gauge length. So, ayun nga. Meron ka ditong specified na length. Sineset mo yan or minamarkahan mo doon sa sample. And that represents the gauge length or yung original length ng bar. The testing machine elongates the specimen at a slow, constant rate until the specimen rupture. So, unti-unti daw or unti-unti niyang ina-apply yung force, palaki yan ng palaki. Again, as we all know, that yung stress is just equals to force over area. So, do sa test na yun, ipapakita yung may graph kasi dyan, iplaplat mo yung strain versus do sa stress. Okay? So, the testing, during the test, continuous reading are taken of the applied load and the elongation of the gauge length. So these data are then converted to stress and strain. Okay? So again, yung stress is obtained, again, as discussed in our module 1, stress is just equals to P over A, where P is the load and A represents the cross-sectional area of the specimen. So guys, kapag nag-section ka dito, ayan, pag pinutol mo yan, ano ba yung makikita mo? So lagi naman yan, circular section. So yan yung magre-represent sa area. And then again, itong P, ito yung slowly na force na ina-apply mo dun sa iyong specimen para makuha yung value ng stress. Okay, so the strain is computed from, ayun nga, epsilon is equals to delta over L, where delta is the elongation of the specimen, or the elongation between the gauge marks and L is the original gauge length. These results, which are based on the original area and the original gauge length, are referred to as the nominal stress and strain. Okay? So as the bar is being stretched, its cross-sectional area becomes smaller. So, di ba? Ano ba pwedeng example dito? So, habang ina-apply mo yung force, kung mapapansin nyo kasi, nagkaaroon siya ng necking na tinatawag, or yung area niya is unti-unting lumiliit sa gitna. Ayan. And again, yung area na yan yung gagamitin mo din ulit dun sa formula for the stress. Dividing the load by the current area of the specimen, we get the true stress. Okay? So, yun pala yung true stress. Similarly, the true strain is obtained by dividing the elongation, delta, by the gauge length. And guys, again, yung delta mo kasi, mag-increase din yan. Kasi, di ba, nag-i-stretch nga yan. So, yung original gauge length niya, so, lumalaki rin siya or nag-i-increase in value. So, when you plot the result, do sa stress and strain diagram natin, kung saan yung stress, ito yung nasa y-axis, and then yung strain, siya yung nasa x-axis. So, plotting this, ito yung mga, typically, ito yung mga nagiging itsura ng yung stress-strain diagram. Okay? So, the stress-strain obtained from the standard tension test on a structural steel specimen. So, ganito yung nagiging usually itsura ng mga sample if steel specimen yung tinetest natin. Again, there are a lot of materials na ginagamit sa construction. So, usually lang, ang ginagamit natin is steel. O, di ba, sa mga steel reinforcement. So, as seen in the stress-strain diagram, is a straight line from the origin to a point called the proportional limit. So, dito, proportional pa yung natin, value. As you can see, when you increase the stress, the strain is also increasing. And at this point of the proportional limit, kapag binitawan mo daw or nirelease mo yung force na naka-exert sa kanya, babalik ulit siya sa original shape. Okay, so yan yung proportional limit. And then from this proportional limit, dyan mo makukuha yung iyong constant, yung kung maaalala sa mga problem na sinolve natin, yung E or yung Young's modulus of elasticity. Okay? So sinasabi lang kasi doon, yung stress mo nga is directly proportional. Kaya nga proportional limit doon sa strain mo. And then this proportional, ayan, inilat natin siyang K. So, from where yung K mo can be represent as your modulus of elasticity. So, yung modulus of elasticity mo is just equals to stress over the strain. Okay? So, I believe ito naman is na-discuss ko rin sa introduction. So, ayan yan. So, as seen in the, ito pala, pinakita sa baba. So, as seen in the stress-strain diagram is a straight line from the origin O to a point called the proportional limit. So, this plot is a manifestation of the Hooke's law. Okay, so Hooke's law pala yan. States that the stress is directly proportional to strain, which gives the equation. Yan. So ito din yan. Ano? So ginawa ko lang yung E ko, inilet ko muna siyang K or yung constant K. Where E is a material property known as the modulus of elasticity or also known as the Young modulus. So its unit is same as stress, okay? So kung saan yan ay force over length squared or force over area. And usually in SI, ang units natin ay gigapascal or pwede rin megapascal. Ano? So it's up to you. Depende do sa mga given do sa problem. Pero ayan nga. So example here. So for the steel, ito naman is constant yung ano niya. So tandaan nyo na lang yung mga numbers na yun. And lagi nyo rin naman gagamitin to. Especially in steel design and reinforced concrete design. So in SI, that is 200 gigapascal at saka sa English, so that is 29 times 10 to the 6 PSI. Alright, so let's proceed with the next page. So guys, under this, ito yung mga different stages do sa iyong stress strain diagram. So when the stress is no longer proportional to the strain or yung shape ng iyong graph is not linear anymore. Ayan, hindi na siya straight. May mga pakurba-kurba na yan. So, ito na yung mga different stages. Okay? So, for the first one, we have the elastic limit. So, under this stage, the stress beyond which the material is no longer elastic. Okay? So, the elastic limit is slightly larger than the proportional limit. However, because of the difficulty in determining the elastic limit accurately, it is usually assumed to coincide with the proportional limit. So, ito yun. Ito daw yung point kung saan, ayan, nag-coincide. Okay? So, almost kasunod lang talaga ng proportional limit natin. Okay? So, ayan yung ating elastic limit. Next, under the yield point. So, ano ba yung sinasabi sa yield point natin? So, this is the point where the stress-strain diagram becomes almost horizontal. Okay? Almost horizontal. Or, ito nga yung point kung saan tinatawag siya as yield point. And it states here that the corresponding stress is known as the yield stress or yield strength. Okay? So, beyond the yield point, there is an appreciable elongation or yielding if the material without corresponding increase in load. So, without increasing the load, eto nga siya, naging almost horizontal na siya. Meaning, even maliit na force na lang yung i-applied mo, magkakakita ka dyan or ma-observe mo dyan na there's a deformation or the sustain mo nga, malaking increase in strain considering na maliit na force lang yung ina-applied mo or small increase in force which results to a big or higher value of deformation or strain. Okay, so kaya naging almost horizontal siya. Pag ano na siya, ayan. Ayan. So, konting for increase lang ng force, malaki yung nadadagdag sa strain. In short. Next, ultimate stress or ultimate strength or stress. So, this is often called the highest stress. Ayun nga. High stress in the stress strain curve. So, highest point. So, syempre, ito na yung pinaka-peak. Okay? Ultimate strength. Next, under rupture stress, meron tayong dalawang klase niyan. So, under this, it is the stress at which failures occur. So, dito na nagkakaroon ng pag-fail or kung maano nyo, magbe-break na yung specimen mo or malalagot. Nominal rupture strength, yung unang type. So, this is considerably lower than the ultimate strength. Okay? Because the nominal rupture strength is computed by dividing the load at rupture by the original cross-sectional area. So, ang ginagamit dito sa nominal rupture strength is yung niya, original cross-sectional area. Di ba kanina, as discussed, meron tayo ng true area. So, yun yung ginagamit sa true rupture strength. So, meron ang stage nga na necking or lumiit yung area mo dun sa point kung saan magkaaroon siya ng rupture or yung point na magkaaroon siya ng breakage. So this is calculated using the reduced area or yung true area nga, where the fracture occurred. So the difference in the two values results from the phenomenon known as necking. So yung difference daw pala ng result ng dalawang yan. So yan yung phenomenon na tinatawag na necking. Okay? So ito siya. Yan, difference ng dalawang to. Yan yung necking. Okay? So again, ang area dito na ginamit under true rupture, tandaan nyo na lang yung word na true. Yung true area. And then dito sa nominal rupture strength, yung original area. Okay, so kung illustrate mo yan, ito yung true area do sa rupture point A true, and then ito yung A original. Alright? Okay. So next, pumasok naman tayo, pumunta naman tayo do sa actually loaded bars. Okay, so under actually loaded bar, ayan, meron tayong figure dito kung saan meron kang specimen or sample which is rigidly fixed do sa isang end, and do sa kabilang end, meron siyang naka-applied na force P. So as shown, meron kang length, original length or yung haba ng specimen mo, and yung cross-sectional area. Okay? So we assume that the stress caused by P is below the proportional limit so that Hooke's law is applicable. Okay? So under this type of problem, so under siya ng proportional limit. Because of the bar deforms uniformly the axial strain, which upon substitution into Hooke's law yields therefore the elongation of the bar as delta is equals to stress L over E, or equals lang siya sa PL all over EA. Pero yung akin nga, pla eh. Dito, pli. Pero mas madali nga naman din tandaan. Tandaan nyo lang yung word na pli. Okay? So again, ito naman, alam ko, may binigay ko na rin yung formula niyan. Or pinakita ko doon sa first part yung derivation ng formula. Kung saan nga, again, ang kailangan nating malaman na equation is yun nga, P over A. And then, yung formula for strain, delta over. Okay, so from that equation, na-derive nga natin yung equation na to. Okay? So, under Hooke's law, again, or proportional limit, so sabi nga, stress is proportional to strain. So yung naano nga natin kanina, yung EE. Ayan. Substitute mo to, P over A. Ito, delta over L. So pag nire-arrange mo yan, ito yung mabubuo natin. Sorry. Ito, ba't naging ano to? Ito ay E, yung Young's modulus. Ayan. So paikot-ikutin mo lang, ito yung mabubuo. So again, ito yung formula. So if the stress or stresses in the bar is not uniform, or yung specimen mo, kung dito, may example rin ako nito eh. Yan. So magkaiba yung cross-sectional area niya habang lumalayo doon sa ano mo, specimen. Papasukan mo siya ng integral. So ayan naman, may formula rin naman na binigay. So ano lang to, salpak mo lang. Mauuha mo naman yung sagot siya. So under 2.4, generalized Hooke's law. So eto, as you shown in the figure, the initial shape before mo ma-apply yung load P. Ayan siya. Yung naka-dash line. Ano? And then the deformed shape, eto siya, upon the application ng load P. So mapapansin yun, mas sumaba siya, and at the same time, yung cross-sectional area niya is lumiit. So, under A, uniaxial loading or yung Poissons ratio nga natin, as illustrated in the figure above, when a bar is stretched by an axial force, there is a contraction in the transverse dimension. Okay? The ratio of the transverse strain to the axial strain is constant. For stresses within the proportional limit, this constant called is the Poissons ratio, denoted by yung V. Ito. Pero on other books, yung symbol niya is yung V din na parang social. Ang tawag dyan is new. Okay? Where yung equation niya is given by this equation. Okay? Yung strain in Y is equals to sa strain in Z. Tapos, is equals yan do sa negative ng nu times do sa strain ng with respect to sa x direction. Okay? So, ano nyo na lang, palatandaan nyo dyan kung nasaan yung actual force, nandun yung nu. Okay? So, dito, nandun sa strain in x direction. So, for uniaxial loading in the x direction, as shown in the figure, ito nga yung equation. Poissons ratio is nu is equals to total strain E sub t over E sub x, where E sub t is the transverse strain, The minus sign indicates that the positive strain elongation in the axial direction causes a negative strain or yung contraction in the transverse directions. Okay? So, negative sign, ayun nga, kaya naging negative daw siya. Indicates that it is a positive strain or elongation siya. In the axial direction causes a negative strain in the transverse direction. Okay? So, kapag contraction, yung P mo is paloob lang. Okay, so with that, given here is the formula. So, strain in X is equals to stress in X over E. Or the equation will now become, eto, pinalitan mo lang, yung relationship nito nga, sinaksak mo dito. Okay, so ano pa rin to yung sa ano natin, yung proportional limit. Doon din naman nakuha to. Yung nga stress is proportional to strain. Ayan. So, sinubstitute lang natin to. Ito siya eh. Strain in x direction. Kaya naging ganito. Okay? So, using the stress in x, ayun nga, is equals to Young's modulus times the strain in x in equation 2.8 yields the generalized Hooke's law for uniaxial loading. From where yung stress mo in y and in z direction is equals to 0. Kasi uniaxial pa lang siya. Ngayon, meron tayo ng variation by axial loading, meaning meron ka ng dalawang axis kung saan meron kang stress or force na naka-applied. Okay? So, for this example, in figure A, meron kang stress in y and x direction. Ayan. So, ito yung equation na gagamitin natin. Pero again, tanda ko may na-share din naman ako. Ito na lang yung pinapasaulo ko sa inyo. Yung triaxial loading. Kasi ang isaset mo lang dyan, for example, yung strain in X. So, kung ang existing lang is strain in X and Y, so, syempre, ang magiging value lang ng stress in Z mo is equals to 0. And kung mapapansin nyo, itong equation na to is kapareho lang ng equation dito, do sa biaxial loading. So, guys, kahit ito na lang yung sa ulihin nyo. Para at least mabawasan lang. Okay? Next, under C, shear loading. Hindi naman tayo masyado nag-focus dito. Pero again, nagbigay naman ako ng example. So again, basahin natin. The shear stress causes the deformation shown. So the length of the sides of the elements do not change, but the element undergoes distortion. Okay, so kapag nagdi-distort ka, or initially nga, yung shape ng iyong sample, for example, ito, square rod. So, nung na-apply yung forces mo, nagkaroon siya ng shear deformation, or kung mapansin nyo dyan, nag-distort. Iba pa to sa torsion. Okay, so ito is nangyari because of the shearing. And so coming from a square or a rectangle, naging siya, parallelogram. Okay, so ang equation natin is tau is equals to, parang siya. Ito, shearing stress nga yung formula. Is equals to G or yung G nga natin is the modulus of rigidity. And yung sigma, gamma, or yung shear strain natin. Okay? Ayan, binigay naman pala dito sa baba. Gamma, yung symbol na gamma is ano rin siguro familiar na rin ng mga dito. So, usually nakikita nyo siya sa soil, geotech, at saka sa hydro fluid. Okay, the shear strain which measures the amount of distortion. Again, yung shear strain natin. So, this is used to measure the amount of distortion. So, is the angle gamma, lowercase Greek gamma, always expressed in radian. So guys, tandaan yung gamma natin, ang units niya is radian dapat. Okay, so most probably, or ang ibibigay dito is yung value niya is in degrees. So kapag ganun yung case, or kung hindi man degrees, ibibigay sa inyo itong makukuha mo itong value nito, tsaka ito. Ayan. So makukuha mo yung angle. Once na nakuha mo yung angle, pwede mo nang kunin yung equivalent value niya in radian. So, di ba 360 degrees over 2 pi rad? Or 180 over pi? Or pi over 180? Okay, so with this, it can be shown that the relationship blah blah blah, elastic range. So, we have also another equation. So, this is for the material constant G. O yung mas kilala nga sa tawag na modulus of rigidity. Or dito, the shear modulus of elasticity. Ayan yung dalawang tawag sa inyo. Pero ang ko dito, ito yung kadalasan na tawag sa modulus of rigidity. So the equation for that is G is equals to modulus of elasticity E over 2, and then the quantity of 1 plus the Poissons ratio mu. Okay? And yung shear modulus, ang equation niya or yung units niya is in the same as yung sa modulus of elasticity. Sa either Pascal yan or PSI. Okay, so for 2.5, so this is a discussion for the statically indeterminate problems. Alright. Ito, madalas ko rin naman sinasabi na ito sa inyo. Again, kapag statically determinate yung problem, it states that the equilibrium equation are sufficient to calculate for the forces that acts on the body. So the number of unknown forces is always equal to the number of independent equilibrium equation. Now, if the number of the unknown forces exceeds, if the unknown forces exceeds the number of independent equilibrium equation, then it is now categorized as a statically indeterminate problems. So, statically indeterminacy does not imply that the problem cannot be solved. So, sabi nga, in-underline ko pa dyan, hindi ibig sabihin na pag statically indeterminate, hindi solvable yung problem. It simply means that the solution cannot be obtained only using the equilibrium equation alone. Statically indeterminate problems always has geometric restriction imposed on its deformation. Okay? So, the mathematical expression of this restriction known as the compatibility equation. Ayan. So, ito yung additional equation ng mga galing do sa geometric restriction or yung sa mga deformation natin. So, ang tawag sa kanya is compatibility equation. This provide us with the additional equation needed to solve the problem. So the term compatibility refers to the geometric compatibility between the deformation and the imposed constraint. So because of the source of the compatibility equation is deformation, this equation contains as unknowns either strains or elongations. We can, however, use the Hooke's law to express the deformation measures in terms of stresses or forces. Ayan. So, based do sa Hooke's law nga natin, kasi nga, ang inaaral natin dito is yung under proportional limit lang. So, pwede mo ring daw isingit yung sa natutunan natin sa module 1, yung stress. Yung concept ng stress, yung force over area. So the equation of equilibrium and compatibility can be solved for the unknown forces. So guys, next, these are the procedures in solving statically indeterminate problems. So step number 1. So draw the required free body diagram and derive the equations of equilibrium. Okay, so yun naman yung initial step talaga. Ito-drawing mo yung FBD niya, ilalagay mo yung mga internal forces, mga reaction. Ayan, kung magsa-section ka, ipakita mo. Tapos, ilatag mo dyan yung available equation na considering yung equilibrium equations natin. So, step number 2, so dyan napapasok yung sunod. So, derive the compatibility equations. And take note that in this type of problem, to visualize the restrictions on deformation, it is often helpful to draw the sketch that exaggerates the magnitude of the deformation. So sabi dyan, sketch that exaggerates the magnitude of the deformation. Usually kasi guys, yung mga deformation naman talaga dito is maliliit, usually in mm lang. Kung i-scale mo yung drawing na yan, sobrang liit niyan. So to help you to easily analyze a problem, i-exage mo daw yung drawing, palakihin mo yung mga deformation para kitang-kita. And then, mas madali siyang ma-analyze, So, palakihin mo lang yung deformation. I-exage nyo para kitang-kita. Para kapag naglatag ka ng mga, niyan, yung mga, yung mga angle theta, madali mo makikita kapag malaki yung drawing mo. Compared do sa maliit na, hindi mo makita ng ayos. So, step number 3, use Hooke's law to express the deformation, strains in the compatibility equation in terms of forces. Yun. So, pasukan mo na ng Hooke's law. And then last, solve the equilibrium and compatibility equation for the unknown forces. So, on before, under equilibrium equation, usually 2 or 3 equations lang. Ngayon, so, magiging 3 to 4 na siya. Ano lang yan? Parang dadagdagan ka lang ng equation, method of elimination, kuha mo yung sagot. Ayun. So, saan nga nanggaling yung isang equation, yung compatibility? Yun nga, sa relationship ng iyong mga strain or yung deformation nga natin. Next, for thermal stresses naman, ayan. So, in thermal stresses, an increase in temperature results in expansion. Increase in temperature o kapag uminit, nag-expand or nag-elongate. And vice versa, kapag decrease, temperature decrease, contraction or shortening. So this deformation is isotropic, so meaning the same in every direction, and proportional to the temperature change. It follows the associated strain called the thermal strain given by the equation. That strain in terms of the thermal is equal to alpha. Again, yung alpha natin, so this is a material constant. This is a material property known as the coefficient of thermal expansion. So, delta T, so this is the change in the temperature. So, if the temperature change is uniform throughout the body, the thermal strain is also uniform. Consequently, the change in the direction, in any direction L of the body is given by, so ito yung equation natin, yung delta T is equals to the strain considering the temperature times L, or that is equals to alpha delta T times L. Pero yung akin nga ulit, di ba ang ano ko dun, alpha lat L times delta T. Alat. And kung marirecall nyo, I don't know if na-discuss na sa inyo sa surveying, pero yung handle ko, measurement of horizontal distances, yung correction due to that sa mga tape, di ba? Familiar din kayo dito. Nagkita na kayo nito sa surveying. And also, the previous one, yung correction due to the pull, yung plae. Okay? So, ayun. Yung topic na to, makikita mo rin sa fundamentals of surveying. Kasi ayun material property, kung steel tape yan, ayan, material niya is steel. So, maano niya to, may experience niya to. So, kapag nagsusukat ka ng mainit, yung climate mo, kung ang measuring tape mo is standard at this temperature, for example, standard siya pag 30 degrees. So, pag nag-exceed nyo yun, magkaaroon na siya ng thermal deformation. Okay? So, yun yung ginagamit natin sa correction. So, same concept natin dito siya. Okay, so next, what are the procedure in deriving the compatibility equations? So, ito yung mga gagawin. Step-by-step procedure in solving a problem considering a thermal deformation. So, step number 1. So, ang sabi nga, remove the constraint. Tanggalin mo daw yung constraint niya that prevent the thermal deformation to occur freely. So, ang tawag dito, this procedure is sometimes referred to as relaxing the support. I-relax mo yung support. Tanggalin mo yung, kung fix yan, tanggalin mo yung isang fix. Hayaan mo siyang mag-deform because of the temperature. So, it's either mag-contract yan or mag-expand. Hayaan mo siya. Show the thermal deformation on a sketch using an exaggerated scale. So, ganun din. Exage mo yung mga deformation na mangyayari dyan. Next, apply the force that are necessary to restore the specified condition of constraint. So, ngayon, maglalagay ka ng force kung saan yung force na yun, ang goal niya is to restore yung material mo back to its original shape. So, add the deformation caused by these forces to the sketch that was drawn in the previous step. Or draw the magnitude of the deformation so that they are compatible with the geometric constraint. So, syempre, kung may force yan na required para ibalik siya sa original shape niya, so magkaaroon siya ng axial strain. And then, yung based on the figure or the diagram na na-drawing mo, i-relate mo ngayon. And then, from that relationship, compatibility, doon mo mabubuo yung additional equation or yung compatibility equation mo. Now, step number 3, so by inspection of the sketch, write the relationship, yung pa pala ito yun, dito pa pala siya, between the thermal deformations and the deformation due to the constraint force. Ayan. So, ito yung step-by-step procedure, wala ang gagawin, kundi sundin lang yan. So, the rest, depende na yan sa kung paano mo siya i-analyze. Ano? So, dapat magaling ka mag-imagine dyan kung ano yung mangyayari dito sa body na to. So, sabi ko nga, imagine mo na ikaw yung bakal. Ano ba mangyayari sa akin kapag ganito? Lumamig na ganito or uminit. Ano ba mangyayari sa akin kapag na-experience ko tong ano? So, kung may katabi ako or pag may mga, di ba yung mga bar na ano? Kung may katabi ako, ano ba yung magiging epekto sa kanya kapag nag-deform ako ng ganito? So, parang ganun ba yung mindset? Mindset ba? Mindset. Okay. So, guys, that ends the summary or the review of what we've discussed for Chapter 2 or Module 2, Strain. So, next meeting natin, again, we will have our prelims exam. So, guys, again, please review your notes. Sagutan na yung mga practice problem, yung mga problem sets sa inyong module. Okay, guys, so that ends our discussion. So, thank you and see you on our next video lecture. Bye.